Hello everyone, my name is Ben Eady. I'm the online media manager of ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar titled Elements of Requirement Style. Today's featured speakers are Carl Wiegers and Joy Beatty. The webinar will last approximately 60 minutes, including the Q&A session. So make sure to submit your questions in advance using the questions feature of the webinar software. And I'd also like to say thank you to C-Level for sponsoring this event. And at this time, I'll turn it over to Joy to get us started.
Hi, thanks, Ben. Thank you everyone for joining today. We're really excited about Carl's webinar. I'm happy to be part of this presentation. First of all, as Ben said, my name is Joy Beatty. I work as a business architect at C-Level. We're a professional services and a training organization. We work with Fortune 1000 companies to help ensure that only the most valuable features are getting built in software. We deliver public and private training to help teach requirement skills ranging from the basic requirements to elicitation facilitation and then requirements modeling. Everything we do is based on our book that came out last summer, Visual Models for Software Requirements. You see that icon up there on the left side. So we're pretty excited about that book. One of the biggest areas of failure on projects, we think, is the lack of IT and business alignment. And core to aligning these two groups and organizations is our favorite subject, requirements. If we can get the requirements right, we can deliver products to our customers that not only deliver success for the business, but delight them too. So I'm really excited about Carl's webinar because it's all about building that solid foundation of requirements that we also need in our projects. One more thing, in other exciting news, you see the book icon on the right on this screen here. Carl and I are working really closely together right now on a third edition of his book, Software Requirements. I'm sure he's going to have more to say on the topic, but just to give you kind of an idea of what's coming in the third edition, we're going to enhance the practices and talk about how they work on agile projects. We're adding techniques and tools for elicitation and modeling, and then we're adding some chapters that talk about specific types of projects and how we apply the requirements practices in those types of projects. And then, of course, the business analysis profession has gained a lot of momentum in the last few years, so we're going to do due diligence to that and give it some more recognition. At the end of the webinar, I'll point you to some other resources that C-Level offers on our site for you. But for now, I'm going to hand it over to Carl.
Thank you, Joy. Welcome, everybody. Greetings from Portland, Oregon. Thank you for joining us today. Thanks also to C-Level for sponsoring this webinar. Much of the material in this presentation is based on my book, More About Software Requirements, and other sections are based on the Software Requirements second edition book. And as Joy mentioned, we're presently co-authoring the third edition of this book, which is scheduled to be published on August 22nd. The book is already available for pre-ordering from Amazon, O'Reilly.com, and other sources. And as Joy mentioned, this is going to be a major enhancement over the second edition. It's been a real pleasure working with Joy on the book, and she's added a lot of really valuable input. Right now, we kind of feel like we're juggling flaming chainsaws with all the things that are going on, but we're making good progress and looking forward to seeing the final product. So here's a little information about me. Feel free to visit my website, processimpact.com, where you can get a lot more information about templates, checklists, training materials, and other resources for requirement engineering, peer reviews, project management, and other software topics. This slide shows some of my other books. The one on the right is kind of interesting. My first non-technical book was published a couple of years ago. It's a memoir of life lessons called Pearls from Sand, How Small Encounters Lead to Powerful Lessons. It's rather different from my software books, but still quite interesting, and it was a lot of fun to write. I also have a blog that you see at the bottom there, Consulting Tips and Tricks blog, with lots of suggestions on things that are useful even besides people who are consultants. So let's dive into what we're going to talk about today. At the end of this presentation, you should be able to describe some ways to distinguish good requirements from evil requirements. I'll give you some common characteristics that we like to look for in good requirements. You should be able to describe several styles of writing software functional requirements. We're going to be focusing mostly on functional types of requirements. I'm going to point out some of the weak words, some of the vague, ambiguous words that I just hate seeing in requirement specs. And you know, I see a lot of these. One of the things I've done a lot over the years as a consultant is review requirements documents of all kinds for all sorts of clients. And you see an awful lot of these kind of vague, fuzzy words, and so it's not really surprising that people have problems having confidence that they're building the right products when we have these sorts of fuzziness in our communication. So I'm going to warn you about some of those. Also, ambiguity is one of the real biggest problems with requirements. Ambiguity shows up in a couple of ways. One type of ambiguity shows up when I read a requirement and I can think, could mean this, could mean that. I can think of multiple possible interpretations just on my own. But the other kind of ambiguity is even worse, and that's when different people read a requirement. It makes sense to both of them, so they say this is fine, but in fact it meant something different to each of them. And in fact, if you just pass requirements out to a group of people to review on their own and let you know what they see, you're not going to catch those kinds of ambiguity because we don't have an opportunity to compare my interpretation of a particular requirement to your interpretation to another person's interpretation. Incidentally, a good way to catch that sort of ambiguity is with a formal peer review, such as an inspection. I'd love to talk about inspections, but that's another topic for another day. So I'll warn you about some of the common kinds of ambiguity, and then we'll talk just briefly about the common issue of having solution ideas or design constraints embedded in requirements. I'll give you some suggestions of how to detect and try to avoid having unnecessary or inappropriate or premature solution ideas in the guise of requirements. I think it's worth keeping in mind as we go along here what the primary goal, the main objective of writing requirements, no matter what form of requirements communication you're using, the primary goal is clear and effective communication. This is the principal objective for all requirements. It's not a matter of conforming to some standard for requirement style or following some particular rules that you might have heard about how to write requirements, or what words to include or what words to avoid. Our goal is clear and effective communication. I've heard a number of kind of silly rules over the years that people have suggested that they heard from somebody else about, how to write requirements. Somebody told me that a requirement may not contain the word and, because if it has an and, then it's two requirements. Sometimes that's the case, but certainly not always. Some people say, well, a requirement cannot have more than one sentence, and I think that's not true. There are certainly times when it's useful to have more than one sentence to communicate the idea. Sometimes, though, you go the other extreme. I've read requirements documents that had whole paragraphs of things, and you can't really figure out what the requirement is in there, so that's not good. Some people say a requirement may not contain more than one instance of the word shall, which is commonly used to identify specific requirements. Even that's pretty iffy. It's not always necessary. And somebody told me once, I thought this was kind of interesting, a requirement could not have more than 22, or maybe it was 23 words. I don't really understand what they were getting at there. Actually, the principle is not bad. The idea is to write clearly and concisely, and really long sentences are harder to understand. But arbitrary limits like 22 or 23 words are just silly. So if the requirements don't clearly convey the intended information to their various audiences, then the requirements are inadequate for this purpose of clear and effective communication, even if they did follow all the rules. And when you're writing requirements, you need to know who your audience is. This is rule number one for anybody writing anything. Know your audience. Actually, it's know your topic is rule number one, but you can kind of fake that, but you do have to know your audience. So you have several audiences for requirements. We have people who are going to be doing work based on the requirements. Sometimes I call them the victims of the requirements. Architects, designers, developers, programmers, testers, maintainers, anybody who's going to have to use that information to do their part of the follow-on work. We have users and customers and other stakeholders. Users are a subset of customers, customers are a subset of stakeholders, and all of those people need to contribute to and understand the requirements. We have project and program managers who are going to have to take that information and make appropriate plans and estimates and allocate resources and make commitments. So there's a lot of people you write this information for. And the best way that I know of to tell if the requirements are sufficiently clear and adequately, appropriately detailed is to have some of these people who will have to do the work based on the requirements review them to see if they meet their needs. By nature, we tend to write things from the author's perspective. We say, well, here's the story I wish to tell. But in fact, you should always be writing requirements and everything else from the perspective of the consumer of the information, not those who are producing the information. So I think developers and testers are critical reviewers, as are customer representatives. We have to get representatives of these different perspectives involved to see if we've achieved this goal of clear and effective communication. When we're talking about specifying functionality, there are several reasons why that's an important thing to do. First, the analyst who's writing the requirements, and I'm going to use the term BA or analyst just to refer to whoever is doing this work, they need to communicate unambiguously to the developers what they are and are not supposed to implement. So this is particularly important if the developers are not in close physical proximity to customer representatives in the BA, such as when you're doing outsourced development or if you're doing multi-site development. And you know, it takes very little physical separation to impede communication. I remember once I was writing software for a guy named John a long time ago who sat in a desk about 10 feet away from me, and we could kind of see each other. So it was really easy for me to have John answer questions. I could just call out, hey, can you come look at this screen, or I can't remember what we decided here, or get a quick clarification. And then I could just move along. But one day John moved to a new office, same floor, same building, maybe 100 feet down the hall and around a corner, and I felt an immediate drop in my productivity because I couldn't get that instantaneous feedback. So we really need to go to more links to clearly and effectively communicate when we don't have people within immediate eyesight. We need to write the requirements for the testers because they're going to rely on the functional requirement specifications to make sure they test all the expected behaviors of the system in addition to any exploratory testing that they might do. The functional requirements that we specify must fully enable the users to achieve the goals they need to accomplish with the system, such as performing the necessary use cases or user stories. If you can do a good job in specifying functional requirements, this helps reveal assumptions and technology issues and risks or constraints that are important to the developer. And finally, unless the functional requirements are properly specified in an appropriate detail, it's not possible to trace them into downstream architecture, design elements, code, and tests that you create during development if you decide to do that sort of traceability. So here are some of the things we're trying to accomplish by doing a good job on functionality specification. So let's look at 10 characteristics that let you distinguish good requirements from nasty requirements. The first thing is that the requirements need to be complete. That means two things, really. It means, first of all, you're not missing any requirements, and I don't know how to be absolutely certain that you're not missing any requirements. It's hard to find missing requirements because they aren't there. They're invisible. So that's a tough problem. We do offer in the book quite a few suggestions about ways to kind of pick up rocks and look for requirements maybe you hadn't found before, but I don't know any way to be absolutely certain that you've got them all. But sometimes you know you're missing a piece of information at the time you're writing a requirement, so you've got a hole to fill, and I like to flag that with a little TBD. TBD means to be determined, which is a known gap in our information. Now, if you just pass along a requirement spec to somebody to implement and it's got TBDs in it, that just means the poor developer has to go figure out how to close those gaps. So make sure that those TBDs turn into action items or issues that we can then try to resolve and close out. We want to make sure our requirements are consistent. Sometimes you write a requirement and over here it says do this, and you write another requirement that says do that. And you can't do both of those. They conflict, or maybe a child requirement conflicts with a detailed or a higher level parent requirement or the requirement from which it originated. So we have to watch out for those kinds of inconsistencies. Requirements need to be correct. They need to accurately state some customer or other external need, like compliance with a business rule or compliance with some regulation or something. And, analysts and developers usually can't judge correctness. We need to have customer representatives participate to make sure that we've correctly translated their needs and statements into actual requirements. But what developers are very good at is judging feasibility. So I like to have a developer involved with the requirements discussions from an early time so that they can raise their hand and say, hey, wait a minute, what you just asked for is going to be really expensive and hard to do. Is there any other way we can approach that? Or even to say, nobody knows how to do what you just asked for. So let's get that voice of feasibility warning us early so that we can work within the realistic constraints. We want to write requirements to be modifiable. Well, of course, you can always change something, but we'd also like to be able to keep records of the changes that we've made, because sometimes you actually have to go back to an earlier version or want to see what change you made and why. So let's write our requirements in a fairly fine-grained way instead of having big masses of them lumped together in paragraphs, and let's give them unique, persistent identifiers so that we can refer to them when we need to and that those won't change over time. Hierarchical numbering systems are prone to change. If you insert a new requirement, that screws up the numbering sometimes. bullet lists are things you can't refer to. So I don't like seeing bullet lists and requirements specifications for the most part. We want to make sure that the requirements we specify are there for the right reason. They document something customers really need. They're necessary. And that means that if someone asks you, well, why are we doing this requirement? You should have a good answer. You should always know where every requirement came from. It's important to prioritize the requirements so we can rank them as to their relative importance of inclusion and their relative timeliness so that we can make good plans to deliver the maximum value in our product as early as possible. To make requirements traceable so that you could link them back to their origin as well as to downstream work products you created because of that requirement, this requires writing them in a way similar to making them modifiable. That is, you write them in a fine-grained fashion with individual, unique, persistent labels on each requirement that you want to trace to something else. We're going to spend quite a bit of time talking about ambiguity as we go along here, but an unambiguous requirement has only one possible meaning that everybody agrees on. And finally, our requirements should be verifiable. Sometimes people say testable, but there are other ways to verify it besides testing. And this means basically that we can determine whether we've correctly implemented each requirement by some appropriate technique that gives us confidence we did the right thing and did it correctly. So one reason you want to have different people participating in reviews of requirements is because different people will look for different things. Testers are good at assessing verifiability. Designers are good at assessing feasibility, and marketing or customer representatives can assess whether the requirements are correct and necessary. So are you ever going to get a set of requirements in which all the requirements have all these fabulous characteristics? No, you're not. You're not going to get perfect requirements. But if you keep these characteristics in mind as you write requirements, then you're going to get better requirements than you would otherwise. And if you look for these kinds of issues when you're reviewing them, you're going to come out ahead in the long run. So let me give you some tips for writing clear requirements. I like to start by evaluating a requirement from the developer's perspective. I imagine I handed a requirement to someone and said, call me when you're done. And if they say, wait, no, I've got questions, don't go. Well, that means we've got to do a little work on the requirements because there's going to be some uncertainties that they'll have to deal with. Well, I like to write requirements in a hierarchical, structured form. I once reviewed a requirement spec with about 700 functional requirements, which is pretty good sized. It was a big project. And there was no hierarchy to it. It was just a long list with some groups of requirements in sets, but no parent-child kind of hierarchy, so you couldn't see those kinds of relationships. And people deal with complexity by using hierarchy in many cases. So that really was a difficult spec to work from. You want to try to write in good English or whatever natural language you're using. So we want to try to keep the sentences and paragraphs relatively short and simple so people can digest them and understand them in bite-sized chunks. I read another spec once that had page after page of textual requirements, but in the form of paragraphs. So I would read a whole page with maybe 3 or 4 big paragraphs on it. And I could understand it. I could see what we were getting at. But I had a hard time gleaning the individual requirements from outside of that mass of text because not only did it contain requirements, it contained context information and background and rationale. And that's all good stuff. It helps people understand better. But we want to make that distinct from the statements of requirements themselves so people know what is it we're trying to build in the solution. Use good English or, again, your whatever natural language you're writing in. Write with proper grammar and spelling and punctuation. There's a very interesting book called Eats, Shoots, and Leaves, which is all about the importance of proper punctuation. It's an amusing book, but it's got a lot of important stuff in it. So if you're serious about becoming a better writer, you might check out that book, Eats, Shoots, and Leaves. We also want to use the vocabulary of the business domain. We don't want to use a lot of technical jargon when we're working with users. People very naturally focus their requirements elicitation discussions on the expected behavior of the system when all goes well, sort of the happy path approach. But any of you who have done development know that you spend a lot of time writing code to handle error conditions, exceptions. So make sure that your requirements explorations also look at the things that could go wrong, how we can prevent them, how we can detect them, how we can handle them, and try to recover from them. Here are a few other tips. Give me just 1 second here. My screen did something a little funny, so okay, I'm back. As I alluded to in the introduction, design constraints are a common thing that sneak into requirements. We'll talk more about that later. But we want to try to avoid imposing unnecessary, premature, or inappropriate design constraints. Design constraints restrict the choices that are available to the designers and programmers, for some legitimate reason. So there's nothing wrong with having design constraints. In fact, we need to know about them. For example, if you're adding some new capabilities to an existing application, you've got a whole lot of constraints to work with. Whatever the current reality is imposing constraints. But let's try not to have any constraints there that we don't have to have. I want to write requirements that are fairly fine granularity, and I've seen the whole range of extremes. One extreme that I saw was in a spec that said it had 3 similar requirements. One said a valid color code shall be R for red. New requirement, G for green. New requirement, B for blue. Those are really too fine-grained. I think we can put those together and no one's going to have any trouble understanding it. And in fact, those weren't functional requirements at all, but rather data definitions of allowed values for some data object called color code. And the other extreme I've seen had a very large specification that had 1 requirement in it. This is for a big editing type tool. And this thing said, the product shall respond to editing directives entered by voice. And that's a really big thing. That's not describing one functional requirement. That's describing a whole speech recognition component. So that needs a lot more detail to communicate the intent to the readers of the requirements. So a good guideline is to decompose your requirements until each one is discretely testable. That is, you could look at a requirement and think of a small number of tests that you could use to tell if it was correctly implemented. That speech recognition one, maybe a few hundred tests. So that's clearly got a need for some more detail. If you see conjunctions like and or in a requirement, don't just discard it. Instead, look at that and say, are these 2 parts of one requirement? Or are they 2 requirements that happen to be combined with the and maybe should be split out? So again, if you would test them in different ways, perhaps you should split them into separate requirements. I think it's important to be precise and specific, not vague and ambiguous. Sometimes people like to be vague because developers are okay with vague. Sometimes that means they can build whatever software they think they ought to build, and customers are okay with vague sometimes because that means that they can reinterpret the requirements whenever they like to mean whatever they like. And that's all great fun, but it's not a good way to build products efficiently. So let's try to be a little more precise. And a traditional keyword that identifies a functional requirement is the word shall or must. I don't care about either of those. But let's not use just a random mix of words like shall, must, should, might, may, could, would, if possible, if you get around to it, if feasible. Let's try to be a little clearer because sometimes people use those words with actual subtle connotations that are different. In certain conventions, which I think are very dangerous, shall means required, should means desired, may means optional. And that's really combining the statement of the requirement with priority, which I think gets very confusing for people who might not be aware of those very subtle distinctions. So let's try to avoid that kind of vagueness. Some people say, well, I don't like the word shall because people don't talk like that, to which my answer is, who cares? So what? It's just a delimiter. It's a flag that says, here comes a requirement, and I see no problem with using that. There's a whole lot of intrinsically subjective and ambiguous and vague words that I just don't like to see in requirements documents at all. So let me warn you about some of these weak words to avoid. Excuse me. If you do happen to have a copy of the Software Requirements Second Edition book, you can find a long list of these words on page 182 and 183. I just happen to remember those page numbers. And I give you some suggestions about how to phrase things differently instead of using these. So let me warn you about some of these. I don't know how to tell if you've minimized or maximized or optimized something. How do you know you couldn't have got it just a little bit smaller or just a little bit faster? People often ask for user-friendly software. I'm sure you've heard that expression from people, and that's great, except for I don't know how to tell if I've accomplished that. See, that's the problem with words like user-friendly and rapid and intuitive. Is that your brain or my brain we're talking about for intuitive? And all these other quality kinds of terms, these are not terms that you can verify. You can't tell if you've accomplished that. So when you see one of these things, a red flag should go up in your brain that says, okay, you don't discard it, but you have a conversation. You say, well, what does user-friendly mean to you? How would you tell if this was user-friendly enough for your environment? Do you have some examples of things that you consider user-friendly or not so user-friendly? So these should lead to some discussions that help you do a more precise and clear job of specifying these kinds of very real expectations that users have about quality. But don't just write down the system shall be user-friendly. That is a worthless requirement. Some others I hear, something should be seamless or transparent or happen gracefully, very, very qualitative terms. Improved or state-of-the-art. Okay, exactly what function is improved by how much? How do we judge if we've improved something enough? Sufficient or adequate, at least. Again, how do you judge that? That's the problem with most of these things, is you can't really judge if you've accomplished it. This is a funny one. I have a little practice exercise I do in a class that includes the word several, and somebody once thought that that was not at all subjective. Several was fine because he interpreted several to mean up to and including 100, which I think is clearly into the realm of many at that point. So words like few and several and some or many, if you ask 5 people around you how many is several, you're going to get at least 5 answers. So let's try to be more precise. Etc. is good. The system shall process characters A, B, C, etc. Where does that list end? We might guess where it ends, but we don't know where it's going to end. Including, and especially including but not limited to, you have no idea what the rest of the iceberg looks like. So including and etc. are very vague terms, very open-ended, that can lead to a lot of surprises later on. Optionally, I never know if that means the developer has the choice of doing something, or the computer has the choice, or the user has the choice, so I don't like that word. And one of my least favorite words in general is support, because it is so vague. Unless you are building a bridge that has to support a certain weight, I don't like to see the word support in a requirements document, because I never know exactly what it means. The system shall support Microsoft Word. What does that mean? Now, the system shall import Microsoft Word 10.0 and earlier documents. Okay, that's fine. But support is very, very subjective. So if you use these kinds of words in a requirement specification, don't be surprised if the various readers interpret them in many different ways and you don't get what you think you're going to get. Now, there are a couple of different structures you can use for writing functional requirements. Some people believe the requirements should describe only the system's behavior, because the system is what you create by implementing all the functional requirements. But I think it's appropriate to write functional requirements from either the system's perspective or the user's perspective. So you use whichever structure on here on style, because my focus is on clear and effective communication. Here's an example of how you might write a functional requirement from the system's point of view. You have some portions to the requirement that look sort of like this. You might state certain conditions that have to be true. When those conditions are true, then the system shall do something. So you see, we're talking about things the system is going to do. And there might be some qualifying statement that you add about performance or some other quality attribute. So here's an example drawn from a system I use as an illustration in many cases, a cafeteria ordering system. So people can order meals from their corporate cafeteria. So when the patron, that's the hungry person, when the patron orders or indicates that he does not wish to order any more food items, the system shall, see that phrase, display the food items ordered, the individual food item prices, and the payment amount. And here the quality goal here is within 1 second. Okay? Now that we can measure. I think we can tell if that's working correctly with a fairly small number of tests. Now, the alternative then is that in some cases it makes more sense to describe actions that the system will let the user take under particular circumstances. So when you're writing functional requirements from the user's perspective, keep this general structure in mind. We want to identify the actual name of the user class, not just user, because this is more informative. The user shall be able to do something, and maybe to some piece of data or some data object. And again, we might have some sort of descriptive information following that. So here's one other example, again from the cafeteria ordering system. The patron shall be able to reorder any meal he had ordered within the previous 6 months, provided that all the food items in that order are available on the menu for the meal date. Incidentally, anytime we pull a requirement out of context like this, and you'll see many of those coming up, they always look at their worst. In context, requirements are generally more informative. But I think you can see that, yeah, we understand what this is getting at, and the overall approach of writing it from things that the user will be able to do as opposed to things the system shall do. So let me give you some tips about good ways to write these requirements. First of all, I like to write in the active voice. Okay, we have both active voice and passive voice. You'll notice the last two examples were written using the active voice. They explicitly identified the entity, either the system or a specific type of user, that takes each action. But a large fraction of the requirements I see are written in the passive voice. They state something that happens, but they don't always make it clear what entity makes those outcomes happen. You just see that there's an outcome, and you are left to figure out, well, how might that take place? So with the active voice, the reader doesn't have to deduce what entity is doing what. It's easier for readers to understand explicit and precisely stated requirements that are written in the active voice. You don't need to make so many assumptions to interpret it. Let me show you a before and after example. Okay, these are almost all of these examples are actually drawn from real projects that I've encountered. So here's one that's written in passive voice. When the output state changes, it is logged in the event log. So we get the idea from that, but my question as a developer would be, okay, who does that? Does the system do that, or a particular subsystem, or some other system that we communicate to, or does the user somehow do that, or is it a manual process, or what? You simply don't know. So if we rephrase that into active, those clarifications jump out. When the output state changes, the system shall record the new state in the event log. And this may seem like a small thing, but it's important. And so I encourage you to go through your requirements and look for those that are maybe written in the passive voice and ask yourself, is anybody who reads this going to know exactly who does what when this requirement is executed? One of the problems is that we aren't really taught how to write requirements in our usual, writings classes in school at various levels. In fact, my background is science. I have a PhD in organic chemistry. And when I was in graduate school many years ago, that was how you wrote, was passive voice and in kind of vague, suggested sorts of ways. That was the accepted style. So I really had to unlearn how to write as a scientist so I could try to write more effectively as a business analyst. So ambiguity is the great bugaboo of requirements. And I mentioned that there's these different kinds of ambiguity. People can interpret a requirement in multiple ways, or different readers can interpret it in different ways. So here's a list that identifies a bunch of types of requirements, ambiguity, and common errors. We're not going to go through this in detail, but we'll see some we'll see some examples of these different kinds of ambiguity on the next few slides. Sometimes it's not clear what we're referring back to. Sometimes it's not clear what the scope of action is. Does this action take place on selected text, or the current line, or current page, or current whole document, or what? Omissions, these missing requirements are very, very common. Something's supposed to happen, but we can't see what stimulates that, or we have a stimulus of some sort, and we're not sure what happens as a result, or you're completely missing requirements, which are very hard to find. And a lot of times we have implicit or assumed requirements that somebody who wrote these just hopes somebody else figures out, and those are kind of scary. Ambiguity in logic. If you have complex Boolean logic with ors and nots and things, in programming we have ways to make this clear with the use of parentheses, but in natural language, like most requirements are written, you don't have that option. And very often when you have a bunch of ors and ands and nots and things, you're missing the else condition. Very common sort of omission. A lot of times people write requirements in a negative way. They say what the system won't do. Again, I'll show you an example. And the worst things to avoid are double and triple negatives. You have to work too hard to try to decipher those. I never don't know what those aren't saying. Try to think about what that means. I never don't know what those aren't saying. That's a triple negative, and you have to really unravel it to try to figure out what it's getting at. Those are bad. Use of synonyms, all sorts of ambiguities we have to worry about, organizational problems, requirements that just aren't in a logical sequence, and boundary values. So let's look at some of these as very specific cases here. Negative or inverse requirements are a very common source of confusion. So here's an example of a negative requirement. All users with 3 or more accounts should not be migrated. Well, I don't even work on the software, and I can say, yep, I've implemented that by doing nothing, okay? So what we want to do is try to say, well, what should happen in a more positive sense? If you can recast inverse or negative requirements in a positive sense, one thing I found is that it almost always includes the word only. We would change this to say the system shall migrate only users having fewer than 3 accounts. Okay, so that tells us what the system will do as opposed to something that it won't do. Here's an example of an omission that we have to worry about. Very common situation here. Okay, the original requirement said the system shall display the user's defined bookmarks in a collapsible hierarchical tree structure. Well, we're all familiar with those kinds of things, so we get the idea of how this works. So let's say you put this requirement in a requirement spec, and you mail this off to some foreign country where people just build exactly what you asked them to build, no questions asked. And so you get your software back, and there's your bookmark. So you find some way, you can click, and boom, it all collapses down. Great. And you look around and say, well, how do I get these back? Oh, you didn't ask to be able to, expand the hierarchy back. You just asked to be able to collapse it. And that's because we were missing something. The system shall display the user's defined bookmarks in a collapsible and expandable hierarchical tree structure. So look for these kinds of symmetrical operations for missing requirements. Very common problem. Don't assume the reader will necessarily know that the user will want to expand back. You hope they will know that, but sometimes that's not what happens. Sometimes people build precisely what you ask them to build. And then you have to be very careful what you ask for. If you ask for an undo function, you might want to also ask for a redo function. All right, boundary values are a very common source of ambiguity in numerical ranges, as well as being a place where you sometimes find missing requirements. So here's a before case. Suppose we're writing a point of sale system for a store, and we've got this business rule we have to follow that says that only supervisors can give refunds, cash refunds of more than $50. So we need to enforce that business rule in the software. And we have a couple of requirements like this. If the amount of the cash refund is less than $50, the system shall open the cash register drawer, because anybody can issue those refunds. But if the amount of the cash refund is more than $50 and the user is not a supervisor, the system shall display a message, call a supervisor for this transaction. Okay, that seems to cover the cases. But what about $50 exactly? Is this a third unspecified case, or is it one of the 2 cases that's already shown here? If so, which one? So the after example here tries to clarify that. If the amount of the cash refund is less than or equal to $50, the system shall open the cash register drawer. And then the second one is basically the same. Okay? So you can also use words like inclusive and exclusive to make it perfectly clear whether the endpoint of a numerical range is considered to be part of the range or outside the range. Ironically, one of my book contracts once had precisely this example in it in the contract, and I don't remember what the thing was, but it was 50 of something. And this is exactly how it was written. The contract described what happened if it was less than 50, what happened if it was more than 50. It did not describe what happened if it was exactly 50. So fortunately, I was alert to that, and we caught it and fixed it. Another source of ambiguity is around synonyms and near synonyms. You want to use terms consistently, and if you have terms that maybe people aren't sure if they're the same or different or just what they mean, create a project glossary. Incidentally, a glossary is an eminently reusable component across an enterprise or an industry. Once you've got those terms in there, you can use them on any project that fits into that domain. I remember once I was writing or was consulting to a company that was doing some software for controlling analytical chemistry instruments in a lab. And at some places in the requirement spec, they talked about chemical samples, and some places they talked about runs. And so I asked the BA who wrote that, I said, well, what's the difference between a chemical sample and a run? He said, well, they're really the same thing. So my suggestion was, pick a term and stick to your story. If you want to define a synonym in the glossary so people know that a chemical sample and a run are the same thing, fine. But an SRS, or requirement specification, is not a place where you want to creatively vary your language in an attempt to keep the reader's interest. Okay? It's a place where we want to try to be clear in our communication. you have to watch out for similar sounding words. This is fairly subtle, but I find this a lot in books that I read now. I read a lot of books just for fun, and more I am finding errors, typos, when the use of homophones, words that sound the same but mean different things. And the wrong one is used. And I don't know why, but all of a sudden I'm just seeing that really, really commonly in just novels and things that I read. So here's an example I found from an actual requirement spec. It's kind of long. It says special day caller tunes, the default, this is for a telephone system, will take priority over all configured individual caller settings that a customer has selected. However, if an individual has been assigned a special day caller tune for the same date, this will overwrite the special day caller tune. So that overwrite jumped out at me, and I wondered if maybe that was supposed to be override. You overwrite with a T, data, but you override with a D, a default value. The problem with these kinds of ambiguities, with all of these ambiguities, is that if a developer or a tester spots the ambiguity, and they aren't sure what it means, they have to go find out. They have to cycle back to the BA or a customer and say, all right, exactly what do you mean here? And so that slows things down, and that's why we want to try to avoid those sorts of miscommunications. Pronouns can be a source of confusion. So a lot of times I'll see pronouns that are referring to something, they'll say this or that, and I'm not sure exactly what it's referring to. So make those pronoun antecedents crystal clear, something we all learned about in school when we learned about writing. My mother is a known pronoun abuser. She'll say something like, he said he'd bring that back when he was done with it, and I won't have the faintest idea of who or what she's talking about. But that's just the way she is. Adverbs are a very common source of ambiguity, and here's a bunch of them drawn from actual requirement specifications. Provide a reasonably predictable end-user experience. Doesn't have to be perfectly predictable, just reasonably predictable, I guess. Offer significantly better download times. Can you think of how to test that and be sure you've achieved it? You want to optimize upload and download to perform quickly. Well, no one wants it to perform slowly, but what does quickly mean? Exposing information appropriately. That probably gets to privilege levels or security kinds of issues. It generally incurs a per unit cost, but no clue was given as to under what conditions it did not incur a per unit cost. So what's the developer supposed to do? Do something as expediently as possible was a good one. Oh, and here's a twofer. Occasionally, but not very frequently, there will be an error condition. I'm not too sure what to do with that. When you write requirements, ask yourself for each statement you put in, whether it's an actual requirement statement or some descriptive information, ask yourself, how would the reader use this information? And if you don't know what they do with it, there might be a problem. And there's a whole lot of other adverbs. Adverbs in general, but not always, end in ly. So all of these kinds of things have the potential of vagueness. So if you find yourself using an adverb, ask yourself if the reader will know exactly what you mean by reasonably, significantly, or appropriately. Will they know what the acceptable tolerance is for something described as being approximately something? They might not. All right, I want to do a little poll here right now. So I'm going to ask you all a question. A couple of abbreviations that are commonly used are IE and EG. And I'm not sure everybody knows exactly what those mean. So what I would like to do is we're going to get a little poll going here, and I would like you to answer the question, are you absolutely certain that you know the difference between IE and EG, those abbreviations? So go ahead and vote in the poll, and we'll see how the distribution comes out here. Just one common sort of thing. So the problem is those are Latin abbreviations. Or really, I should say, they're abbreviations of Latin terms, and it's not obvious that everybody knows, what they mean. All right, so I'm seeing some data coming in here, and it looks like most people do think they know what it means. 53% said yes, they're certain, and 47% said no, they aren't 100% sure. So let's just see what the difference is. IE and EG are commonly confused. IE means that is. It's an abbreviation for the Latin term id est. EG is an abbreviation for the Latin term exempli gratia, which means for example. So if you have a list of things and you say IE, what you're saying is that the list that follows is every item in that list. Okay? And the reader then can be sure that that's all the things they need to be aware of. E.g., however, means for example. So someone could say, the system shall process ASCII characters, e.g., A, B. Okay? You have no idea of what the rest of them are. And those are very commonly used. It would actually be kind of interesting to redo the poll and see if you've changed your opinion now. But if you're not 100% certain, and even if you are, the reader might not be 100% certain. So instead of using confusing Latin abbreviations that are so often confused, just write out what you mean in English. Here's another thing that just bugs me a lot is this construct in which there's an A followed by a B. Okay, I call it the AB construct. One word / another word. And other than a very few exceptions like and, or read, write, I'd avoid using that construct. Here's an example. Prior to operator intervention, a snapshot of this data should be recorded in an audit/history table. And anytime I see that A/B construct, I'm not sure what it means. Does it mean that A and B are synonyms, audit and history are the same thing? Or does it mean audit and history? Or is it either audit or history? Sometimes the A and B are opposite, like I've seen approving/disapproving changes. But you know, a lot of the times when people use this construct, what it means is that the author wasn't sure exactly what he wanted to say, so he's inviting every reader to come to his own conclusion, which is a clear invitation to ambiguity. Let's try to avoid that. All right, I promised to tell you a little bit about solution ideas. Requirements often contain embedded solution ideas which impose a design constraint. These could be perfectly legitimate and necessary, or sometimes they're not. The requested solution describes one way to satisfy some requirement. Perhaps that's not the only way, or the best way, or even a good way. It may just be something that occurred to someone. So when we focus on solutions like this, that really masks the underlying requirement. And this, incidentally, is one of the biggest complaints I've heard from BAs who say that their customers give them solutions, not requirements. So what we're trying to do here is distinguish the real customer need from just one possible description of how a clever developer might satisfy that need. Legitimate design constraints are perfectly appropriate, and developers need to know about them. So you should expect to see more requirements that contain design constraints when you're specifying enhancements for an existing system, because it does impose those constraints. And a good question for the BA to ask is, why? Why does it have to be done a certain way to tell if the constraint is needed? So something you want to listen for with your little BA antenna here is to listen for technology or user interface specifics that might suggest that you're hearing a solution idea embedded in a requirement, and maybe want to question that a little bit more and take them apart. Sometimes you might say, oh, then the user selects a state where they want to send the package from a drop-down list. So that phrase, from a drop-down list, is a flaming clue that you've got a solution idea. Someone is envisioning a specific user interface control. So you ask, why from a drop-down list? The answer might be, oh, we did the same thing 3 or 4 other places, and so I wanted it to be, a same experience for the user, plus that way we don't have to worry about them putting in invalid data. Those could be excellent reasons for doing it from a drop-down list. Or it could just be something that the user thought of or had seen in another application, in which case maybe it's not such a great solution. So explore that and decide whether that's worth including as a design constraint, which means the developer has no choice, or whether it's worth including as a suggestion for the developer just to get a better understanding of what the user's thinking of, or whether you should take the constraint out entirely. I saw this once. The defect calculator should be written in Excel. Again, there might be a good reason, but let's pursue that. Or maybe we're showing messages from a program called the Background Status Manager, and we say the Background Task Manager. We say the Background Task Manager shall display error messages in the status bar. Now, if we're adding a capability to an existing system that has a status bar where people are used to looking for messages, this is perfect. Use that existing construct and as a constraint. But if we're creating something new, then you've eliminated with this statement all the other ways a developer might think to possibly show error messages. So what you can do is use a rationale attribute. You can add 2 functional requirements attributes of various types to give you more descriptive information about them. And by including a rationale, you now have a place where you can provide an explanation of why that constraint was imposed, so that you can maybe cut off debate about it or people wondering, well, why do I have to do that, or just choosing to disregard it entirely. So some things to keep in mind about your exploration here is to understand why the solution idea might be included. Is it just an option that the speaker thought of? Maybe not, anything other than the first thing that popped into their mind. Is it the only possible solution? If so, yeah, we need to know that. Sometimes people are more interested in exploring solutions than in understanding the problem because the solution is more tangible in a way. Maybe it's a poor solution because the problem wasn't well defined or the solution addressed the wrong problem. Okay, so let's ask about that. Maybe it seems like a good solution, but for the wrong reason. It might be based on an assumption that's not true or something that was true in the past but isn't valid anymore. So the solution very well might be worth passing along to the developers as a suggestion, but not as a mandate. So let's try to make that clear, distinguishing the requirement itself from ideas about how to possibly address it. So finally, I want to warn you about some common mistakes that people encounter in writing specifications. One is around assumptions. An assumption is a statement that we treat as being true in the absence of definitive knowledge whether or not it is true. And if you make an incorrect assumption or an obsolete assumption, we can zig when we should be zagging, and we're not always even going to be aware that we share different assumptions. Often people write implementation instead of requirements. They describe the solutions as in the guise of requirements. Sometimes people are talking about business processes or operations instead of actually writing solution requirements. If you write requirements that are unverifiable, you might as well not bother because you'll never be able to convince yourself whether or not it was satisfied. Missing requirements entirely, as I mentioned, are hard to spot but very common problems. So check out the software requirements book for some ideas about how to avoid missing requirements. But you can go to the other extreme too. You can over-specify requirements. You can put in more detail that's necessary. And really what we're trying to do is put in just the right amount of effort to get the right amount of information at the right stage of the project to guide the developers with the intent of reducing the probability of having to do a lot of expensive rework. It's really all about risk management. But putting in massive detail that doesn't have to be there or that's obvious to the reader doesn't really do you any good. And simply writing poorly, using incorrect vocabulary or awkward sentence structure also leads to failures of our goal of clear and effective communication. So I've tried to give you a few ideas very quickly here today of how you can focus on writing clear and then the unambiguous requirement. And really what we're trying to do is to reduce the unpleasant surprise factor that occurs on so many software projects. In my experience, surprises in software are never good news. So thanks for joining us. If you take away only one message from this presentation, remember that without high-quality requirements, software is like a box of chocolates. You never know what you're going to get. So now I'd like to turn the presentation back over to Joy Babi, who will tell you a little bit more about C-Level and will handle the Q&A.
Great job, Carl. That was awesome. Thank you. Okay, so I am going to point you to a couple of resources we have at C-Level that might help you if you're a VA or a manager of VAs. In case you missed it at the beginning, in addition to consulting, we also offer training both publicly and privately. We have a class next week in LA. The classes are on the left column. We've also got Dallas and Chicago coming soon with more to come later in the year. So you can find those on our website. It's www.clevel.com and then /training to get to the courses. But also here on the right side of the screen, there's a bunch of free resources on our website that I want to point you to that might be helpful for you, something you can take away and use today. First of all, I mentioned the models book. We have models templates that you can download. Those are all for use in Microsoft tools like Word, PowerPoint, and Excel. You can grab them in a whole zip file, and you're welcome to use them however you so desire. Out there what we like to call cheat sheets that VAs can take into like elicitation sessions as reminders of types of questions to ask or things to look for. So all kinds of good free stuff out there. And with that, let me go ahead and flip over here and we'll start asking some of your questions of Carl, and or I might chime in as Ben mentioned in the beginning. So let's go back to the beginning, Carl. We had a question very early on that do we need to write the same requirements in different ways based on our types of customers?
I guess the question there is really, is it types of customers or types of stakeholders? And this is one of the problems we run into, because if you think about the various consumers of your requirements, they can be very diverse. You can have, end users. You can have people who are acquiring the software or paying for it and interested in business requirements. You can have developers and testers who are interested in the technical side. So that's a broad range of stakeholders. If you're talking about actual customers, then they may have more similar understandings as opposed to this big range of whole stakeholders. Let me talk about the whole stakeholder range. And this is really a problem, because very often those different stakeholder groups don't need the same level of detail. They don't need the same level of precision. They may want to see a big picture. They may just want to see the business requirements or just the technical side. So very often writing requirements in one form does not meet the needs of all of those audiences. And that's why we like to talk about three main levels of requirements. Business requirements, which talk about your business objectives. User requirements, which talk about things people need to actually be able to do with the software, like use cases and user stories. And functional requirements, which describe the capabilities that developers actually have to implement. And so really, you do need to create those different sets of information at different stages of the project with different audiences, different levels of detail. You also sometimes want to say, who needs to see all the nitty-gritty and the textual write-ups, and who can just get away with a big picture, a visual model that shows them a general idea of what's going on. So in a lot of cases, a single representation is not going to meet all those people's needs. And unfortunately, that means you end up having to create these multiple deliverables and make sure that they're properly synchronized and structured for their main target audience. I don't know any good way around that.
Yeah, I agree, Carl. And there's another question that came in later in the conversation, which I think relates to this. And for the most part, you've answered, but what is the justification for writing requirements from users versus systems perspective? And I think, you kind of hit on it, right? Often your different stakeholders need to see something different. The other thing I would throw out there is that when you get into different methodologies, you might need different levels of representation.
Right, yeah. And I interpreted that question, Joy, a little differently. The justification for writing from the user or stakeholder or system perspective, if I heard that correctly.
Mm-hmm.
I showed those two different styles. You could say the system shall, or a certain user shall be able to. And so that's how I interpreted that question when I saw it come by. And if that was the question, then I would say it's not a justification, but rather a matter of just choosing which of those is going to most clearly communicate the intent to the reader. So really, I would do it more from a natural point of view. Is it more natural in a particular situation to say what the system shall do under certain conditions? Or does it just communicate more naturally to say what the user will be able to do? I'd say that's a judgment call, and I don't think there's a need for a particular justification to do one or the other.
Okay, great. Let's jump to this one here from Denise. So for time frame projects, I sometimes need to have TBDs in order to get development started on what we do now. If I understand what you said correctly, that is okay as long as it is an action or open item list.
Yeah, I would agree with that. If you have a project, sometimes you can't just wait till everything's nailed down, and even for a small block of requirements. There's the classic waterfall approach where we tried to nail down everything, which doesn't work very well. But even if you're just doing a short development increment, you may still have uncertainties and TBDs that have to be resolved, and you don't want that to hold you up. So great, okay, do that. Just recognize that there are gaps, recognize that there are issues, maybe put them in an issue tracking tool even so you don't lose sight of them, and make them part of your day-to-day monitoring of status so that those holes get closed. Because believe me, somebody's going to have to make that decision and close the gap. It really boils down to who do you want to have making that decision and at what point of the project. A wise person once said, look, the requirements might be vague, but the product's going to be specific, and someone's going to be making those decisions.
Well said. Okay, back on the screen that you had about the different characteristics, do you feel like those characteristics all pertain regardless of the development methodology?
Yeah, I showed these 10 characteristics that kind of let you distinguish good requirements from bad requirements, and I'm just trying to see if I can find a way to quickly pop back to that. It might have been around here. Right here. Yeah, the question is, do these all pertain regardless of what kind of development approach you're taking? And I say absolutely. Somebody has to, again, have this information. If the requirements are ambiguous, then I don't care what kind of development you're doing, somebody's going to have to pin it down. Now, if you can pin that down, if you can clarify ambiguities, close gaps, and so forth with just-in-time conversations with the right people, great. Sometimes that's feasible, sometimes it's not. If you're missing a requirement, I don't care what kind of development process you're following, you're going to have a problem. So yes, I think these apply to anything.
I think so, Carl, and I'd add on that, if you're in for example, an agile development methodology, then you may identify requirements and not necessarily hit all of these characteristics up front, but maybe as you dive into an iteration, you would get a little bit more clear on the set that's in that iteration.
Exactly, that's a very good point. And with agile development, one of the most important characteristics is prioritization, so that you can do a first cut of, kind of casting a broad net to begin collecting requirements, but not going into a lot of detail and precision. But then you prioritize those, so you say, which ones do we have to build now? Which ones are we going to build soon? Which ones are we going to build later or maybe never? And then, in a just-in-time kind of basis, you can enrich your understanding of the requirements in line with these kinds of characteristics, but there's certainly no point in doing that on day one for stuff you might never even implement.
Yeah, absolutely. I'm going to ask Ben if we have to cut off because there's a whole bunch of questions here.
If there's a few people here that want a couple more questions, I can't see why we can't do that. How about we go another 5 minutes or so and then cut it off from there?
Okay. Perfect. I will do that. And I'm going to real quickly point out there's a few questions where people are asking us to show a slide that came up previously, and they'll be able to come to the website and see the slides and the recording at that point. So that's probably the fastest way to get them. Okay, how would one distinguish between functional and non-functional requirements?
How does one distinguish between functional and non-functional requirements? Broadly stated, functional requirements describe the behaviors that a system will exhibit under certain conditions or certain stimuli. Non-functional requirements, a lot of people think of those as just being, quality attributes like usability and portability, and really non-functional requirements covers a range of things. Certainly the quality attributes are the broadest category, but I consider non-functional requirements to also encompass constraints that the developers have to work within, and also external interface requirements that describe connections between your system and other pieces of software or users or hardware or communications. But basically, the biggest chunk is the non-functional requirements is quality attributes like usability and reusability and portability and efficiency and performance and so forth. And those things talk about not what the system does, but rather how well it does it. So those are more qualities of the system as opposed to describing just what it actually does. Very quick answer.
Yeah. And one of the things I like to say is worry less about how you're classifying requirements and just make sure you're getting them.
Exactly. A lot of times thinking about requirements during elicitation from the perspective of looking for external interface possible requirements or looking for quality characteristics, sometimes those will reveal information that you didn't discover just from a functional focused discussion. And I agree absolutely with Joy. Let's not get too wrapped around the axle about exactly how we classify things, and I don't want to see you having fistfights in your groups about that. Instead, let's just make sure we discover the information and communicate it to people who need to know it.
Okay, great. All right, here's one about business rules. So should business rules and data definitions be documented with requirements or separately?
An excellent question. Let me handle them separately. Business rules are really not software requirements. Business rules are properties of the business, things like constraints or action enablers that trigger something. They could be corporate policies or computational algorithms or laws and regulations or industry standards you have to conform to. And so those have an existence outside the scope of a specific software application. And the way I think about it is that most business rules apply even if you were performing your operations manually, let alone if you were doing them with the help of a system. So I think it's important to collect your business requirements separately from the software requirements, collect your business rules separately from the software requirements really as an enterprise level asset, but then when those affect certain parts of your system or lead to deriving functionality to conform to the rule, trace back to those so that you know where that functionality came from. Data definitions, I think, are part of your requirements. I like to collect those in a data dictionary, which is part of your requirements documentation, but I don't like to sprinkle data definitions throughout the requirement spec, because let's say you had 5 requirements that dealt with something called a project charge number, for a corporate activity. If maybe you chose one of those as the place where you defined what a corporate charge number or a project charge number is, how does the reader know how to find that information? So I like to collect data definitions into a data dictionary and make it part of the project's requirements documentation.
Okay, great. All right, here's another one. This is a complicated one. What is the suggested method to ensure that all requirements are identified and captured?
I'm not sure really we have time to go through that because it's not a method. There's a lot of techniques that you really want to use during elicitation. And incidentally, everybody, Joy has just written a very comprehensive new chapter for our 3rd edition, which I'm reviewing right now, with lots and lots of guidance about how to do elicitation and good effective techniques to use in different situations. It's going to be a real asset to the new book. And part of that is then thinking about how do you look for possible places where requirements might be missing. So there's no sort of one method that you can use. And like I said early on, I don't know of any way to be sure that you've got them all.
Yeah, I don't think you can. I do think I would add analysis models can really help you find gaps, right? Because sometimes that picture is much more clear than a list of requirements.
Thank you, Carl and Joy, for a very informative presentation, and thank you to everyone for attending today's Modern Analyst webinar, sponsored by C-Level. I wanted to point out the webinar, along with the slides, will be archived at ModernAnalyst.com within a few days. And this concludes today's event. We hope you have a great day.
Bye.